Hi everyone, this is Nick Jacobs, your math instructor for intermediate algebra here at Yavapai College. We're going to go through section 7.3 today, addition and subtraction of rational expressions with like denominators. So we have been, we introduced rational expressions in 7.1. We then multiplied and divided in 7.2, and now we're going to start addition and subtraction. All the problems in this section will have a common denominator, so you won't have to find one or make one as we will in section 7.4. But let's get started. So again, just a couple of objectives today. First, we're going to review what adding and subtracting fractions looks like. We're going to go over some examples that won't be on your homework, but kind of will give us a background for adding and subtracting actual rational expressions with like denominators. So these two first problems here, we're just going to go ahead and add these fractions and simplify them to lowest terms. So again, you won't see these on your homework, but you know, they're kind of good examples just to get us started here when we have a rational expression with variables. So recall, guys, that what we do when we add and subtract fractions is the first thing we do is we look for, does it have a common denominator, right? And this one does, right? So we know that all we have to do is add the numerator, so the 4 plus the 1, keep the denominator of 7, and then 4 plus 1 is 5. Our denominator is 7. So we just keep that denominator all the way through, right? So this is definitely not equal to, you know, 4 plus 1 and 7 plus 7. Does not work like that. Okay. So add the numerator, keep your denominator. Same thing with this one. We're going to add the numerators. The 1 plus the 5 is a 6. I wrote a 6. I meant to write a 9 there for your denominator. So keep that denominator. 1 plus 5 is 6. Okay, so we have 6 over 9. And now here you have a couple different options, right? We could do kind of what we did in the last section to simplify, because this can be simplified. We can split this up into a product of primes and then cancel out a common factor. So this simplifies to 2/3. Or what we could do is, you know, find that greatest common factor, which we know is 3, and then divide top and bottom by that number. So either way, you still get 2/3. I don't care what way you do it. I also, you know, don't care in this case. You can just type that into your calculator and simplify it like that. But when we have variables, you won't be able to simplify it so much. So at least with your calculator. So now subtracting is basically the same thing. So you subtract the numerator and keep the denominator, and then just remember to simplify it to lowest terms. So here we have 13 minus 7 over 18. And 13 minus 7 is 6 over 18, and that can also simplify. So again, you could do the, you know, kind of the breaking it up method here, where we have 6 times 1 over 6 times 3, canceling those common factors to get 1/3, or we could, you know, divide top and bottom by 6 as well. And then here we have 15 minus 11 over our denominator of 30. 15 minus 11 is 4. And then here, this is going to break into 2 times 2 over 2 times 15. So we can cancel 2's on top and bottom, and we have 2 over 15 is our final answer. So just a couple of quick examples there with adding and subtracting fractions with like denominators and simplifying to lowest terms. So same kind of rule applies here to rational expressions. If they have like denominators, we add their numerator and we keep the same denominator. Again, your denominator in a rational expression or just a rational number itself cannot be 0, right? Then it would be undefined. And we've talked many times about that. But let's go through these two examples here. So we're going to add and simplify these rational expressions to lowest terms. So again, in example A here, you look for a common denominator, and obviously x plus 3 and x plus 3 are the same. And then we're just going to go about adding the numerators there. So we have 4x plus 1. Now, what you could do is you could say this is plus the second expression. And the reason I write the second expression in parentheses is because when this is a subtraction, what we're going to have to do is distribute that subtraction. So do you need parentheses in this case when we're adding? No, you don't. But if you want to write it in parentheses like I did, you can definitely do that. Now for the denominator, again, you just keep it. It's x plus 3. And then here, you're basically combining like terms. So I wrote those parentheses. I'm going to get rid of them now and then kind of focus on what your like terms are. So what are the like terms? Well, we have a 4x up here, and we have a positive x here, and then we have a 1 and a -2. So we're going to go ahead, and combine those. So 4x and an x, right? 4x plus x, if you guys recall, is just 4x plus a 1x. So add the coefficients, keep that variable. So 5x. And then a 1 minus a 2, right, is going to be a -1. So in the numerator, I have 5x minus 1, and keep that denominator of x plus 3. And I can't do anything else with that. Some people will try to go along and they'll cancel the x's, but remember we have subtraction and addition. So those make that an expression. You need a factor to cancel out. So you would need it to all be multiplication on the top, all be multiplication on the bottom, and then you can cancel factors. And we'll see that here in just a second. So in this one, we have x over x squared plus 7x plus 10 plus 5 over x squared plus 7x plus 10. So again, we're going to go ahead and add the numerator. So we just have an x plus 5 on top. Keep your denominator of x squared plus 7x plus 10. Now you're not done in this case. All right, you have to look to see always, can you factor the numerator or the denominator, just like you did in the other problems, right? We canceled common factors. This one's no different. And if you notice the denominator, that is a trinomial expression, and we can actually factor that into x plus 5 times x plus 2. And we've done a lot of factoring this semester, and you should kind of be comfortable with that by now here in the last chapter. But what we do here then is we can see that we have an x plus 5 and an x plus 5 on the top and the bottom, and I can cancel those, okay? So that factor cancels out. And what am I left over with on top? Well, when I cancel this, I'm just left with a 1, right? Because I could have wrote this as 1 times x plus 5. So then I would have canceled that x plus 5. So I have one left on top here, and I have an x plus 2 left on the bottom there, and that is as far as you can go. And let's just do a couple more examples of adding rational expressions. So this one is a 7 over AB plus 4 over AB. Same idea, add the numerator, 7 plus 4, keep the denominator, the A and the B. The reason why I'm doing these is because we're introducing 2 variable expressions here. And that might change things up a little bit. It might make things a little bit harder, but shouldn't be too bad for us. So this one is just 7 plus 4 is 11 over the A, B. And this guy, again, we add the numerator, so w plus y. Keep the common denominator, w squared minus y squared. And then notice here that this is a difference of 2 squares. So we can break up the w squared minus y squared into w plus y and a w minus y. And again, we notice that we have a w plus y on top, w plus y on the bottom. And we just have the 1 left over as we kind of did in the on the last slide. So the 1 left over on top in the numerator and w minus y in the denominator. All right, and then subtracting rational expressions is kind of the same. So we just subtract the numerator, so the first one and then the last one, and then keep the denominator the same. So let's just do a couple examples here, and then I think we'll just have one more after this. So, make sure I'm on the right colored pen there. All right, so we have a 6 over x squared minus x plus 6 over x squared. Now this is what I was saying on that example when we were adding, when we had the parentheses around the second expression. You don't need it when you're adding, but it's very helpful to write a parentheses around the numerator of the second expression when we're subtracting. So this would be written as 6 minus, so this minus comes on top, this entire expression, x plus 6. Okay, and then you keep your common denominator of x squared. So you kind of see how I did that. We subtracted this entire thing. Okay, now we need to distribute the subtraction sign. So it's going to be 6, distribute the negative to the x, so 6 minus x, distribute the negative to this positive 6. So that becomes a negative 6 over x squared. And then we see here, we have a couple of common or like terms. So we have a 6 and we have a negative 6. Those two just go away, right? Because those cancel out. 6 minus 6 is 0. So on top, I'm just left with a negative x. And you notice how I kind of box the sign in front of the 6. Okay, so the sign in front always goes with it. This sign over here is just a plus, right? Because it's a positive 6. But we have a minus x left on top over x squared. Now we can still simplify this further, okay? We can think of a negative x as negative 1 times x, okay? So if that's negative 1 times x, and on the bottom we have an x squared, which is also x times x, what I can do there is I can cancel out an x. So I can cancel this, I can cancel this, and I'm left with that negative 1 on top over x on the bottom. And we generally write this negative even with the fraction bar. So it is really, it's equal to negative 1 over x. Hopefully you kind of saw how I did that. You know, you don't have to write this step if you can see that we just cancel an x here on the top, cancel an x on the bottom, and we have a negative 1 left over on top. That's perfectly fine if you can see that. Now here I have, again, check for a common denominator. The denominator is the same. So I go ahead and I subtract the numerators and I keep the denominator. So here in this first expression, I have 2x minus 3. Now I'm subtracting this entire expression. So minus the x minus 4. All over x squared minus 1. So let's go ahead and let's distribute here. So I have the 2x minus 3, nothing happens with that. But now I distribute this negative to both terms inside of this expression. So distribute the negative to the x, it makes it a minus x. Distribute the negative to the minus 4, and that makes this a plus 4. And that's still over x squared minus 1. And then at this point, you're going to combine like terms. So we have this 2x and this negative x. And we have a minus 3 and a positive 4. So the 2x minus the x, what is 2x minus x? 2x minus x is just x, right? 2x minus x is the same thing as 2x minus a 1x. And we're just left with 1x or x, right? Some people will just drop off the x and they'll just get a 2 or something like that, okay? Don't do that. We have to subtract your coefficients, right? So we have an x, and then we have a minus 3 plus 4 is just plus 1. So we have x plus 1 on top over x squared minus 1 on the bottom. Now we recognize that x squared minus 1 is also a difference of squares, kind of like we had on a couple slides ago. So we're going to break x squared minus 1 into its difference of squares, x plus 1 times x minus 1. Remember, you can always FOIL this out, by the way, to make sure that it does match this. Okay, and just in case you want to check your work there. And then we cancel the x plus 1s, which is our common factor. And we can do that after we have all multiplication here. And this could also be written in parentheses, right? So then left on top, we just have a 1. And remember that comes from the fact that we could write x plus 1 as 1 times itself. So we cancel the x plus 1 over x minus 1. And one more question. So we're going to simplify or subtract and simplify this one to lowest terms. So we have 7a over a plus 2 minus a minus 2 over a plus 2. So again, same idea. We have a common denominator. Let's take the numerator and let's subtract it. So we have 7a minus this entire quantity, a minus 2, all over your common denominator of a plus 2. Distribute here. So keep the 7a, distribute the negative here. So I have a negative a plus 2, right? And then all over a plus 2. Now combine like terms. I have a 7a and I have a negative a or negative 1a. That becomes a 6a plus 2 on the top and a plus 2 on the bottom. Now, your MyLab might accept this answer to the homework. I would probably accept it too, except you can simplify the numerator a little bit more by factoring out a 2, right? Because I can take out a 2 from 6a, can also take out a 2 from 2 there. So I'd have 2 times parenthesis 3, oops. Let me erase that. Kind of wrote that right on top of it. 2 times parenthesis 3a plus 1 all over a plus 2. Now I can't cancel any factors here, because we have a 2 out front here and this is a plus 2, but you could kind of go this one step further here. So I would accept either this guy or this one. And that is simplifying. So when we're adding and subtracting rational expressions with the common denominator. Next section in 7.4, we will add and subtract with unlike denominators. So it's going to be a little bit harder. We'll have to find or make a common denominator and then add and subtract from there. So until then, I'll see you next time.